I'm from Zilliqa. I'm the developer advocate there. And I thought today is going to be a mini workshop, so I prepared it as a workshop instead. So let me just go through what the Zilliqa platform could do, and the network topographies, what you can get support from Zilliqa site, and talk about some of the ground programs that we have so far. So the agenda for today, we'll go through the Zilliqa network, introduce you guys to it. We'll go through the smart contract language, which is called Zilla, the fundamentals of how it works, the semantics, and so on, and how you're supposed to develop application from the end to end. We'll give you guys a brief introduction of how to do so, and later on we'll introduce you guys to some of the programs that we have and different channels for discussions. Let's go through the Zilliqa network first. So this is the trilemma triangle that all blockchains will face. We can sacrifice a certain aspect of that triangle in order to achieve a certain kind of properties. So, for example, Bitcoin and Ethereum will go under the bottom left-hand side of things, and I think EOS will probably go on the right-hand side of things, and the top of the triangle, and so on and so forth. You can view some of the different kind of blockchains through this triangle. You have different properties for different use cases. So what Zilliqa aims to do? Zilliqa aims to have reasonable latency for its finality. So we have a 1 to 2 minutes transaction block. Every transaction block will be a finalized transaction. And we have low overhead, so you do not have to have communications bottleneck. Bandwidth is not an issue here because we do not store transactions across the board for memory and send it entirely across the network. And we enable the large number of nodes to be participating in it to validate the transactions. So instead of going for a smaller node count, like for example 30 to 40 nodes, each shard has 600 nodes. So if you expand it to the entire network, having like 5 shards is 5 times 600, you have 3,000 nodes. And as the node count increases, the shards counts will increase, and the parallelization of the network will increase. So you can have things like 10,000, 20,000 DPS, but on a public setting. So there are different kinds of nodes. These are the different kind of types of nodes that's in Zilliqa. You have directory service nodes, a special shard. You have the shard nodes that processes and validate transactions. Seed nodes that they serve the JSON RPC requests and also allow new nodes to join the network. The lookup nodes serve as a DNS system that shard the transactions to the correct shard, and archival nodes stores all the transaction history from the Genesis block. So this is the network topography here. We have a forum post that you can go to take a look at the entire structure with all the explanation. So as we explained previously, is that the archival storage stores all the transactions, the seed nodes serve the requests, and then you'll forward the transactions that's received upon the request to the lookup, and the lookup will serve as a DNS and do transaction assignment to different shards. And each shard of 600 nodes will validate the transactions and perform the PBFT consensus. And that's where your transactions get finalized, and they will form something called a microblock. And each microblock will be assembled into a final block here at the DS level. And that's where you get your parallelization of transactions processing. So that's why you can have close to unlimited scale of TPS when the network scales itself. So let's go into the smart contract side of things. That's which is the more fun part of things, because this is where you will be if you wish to build on Zilliqa. Zilla is a new smart contract that has a certain few features. So it's non-Turing complete, it's recursive, it's nature. What it means is that we have certain properties in mind that we want to have safety properties so that we prevent endless loop that happens within some Bargate programs, and you always know that your program will always end and get the correct output that you want when you put in the input. And it's amenable to form verifications, which means that you can write mathematical proofs that prove that your program is always safe, so that in future, let's say 1,000 years from now, the program will still function the same as you have written it. So this is the reason why we want to build the Zilliqa language this way from scratch is because we realized that for smart contracts, once it's deployed, you cannot change the code, source code, and you need to have at least those aircraft level safety on it. You need to prove that everything can process and work as you expect it to. That's why we created this language to let you do so. Just to go into the basic structure, we separate impure functions and pure functions. So you start with a library first with the pure functions, which means the state of the contract will not be mutated here. Then we separate the parameters for immutable and mutable explicitly. And then we go into transitions, which are basically your functions within a program. And these transitions are basically where you write your statements that you can change the state of a certain contract, which is individualized ledger that you have in your application. So this is a very simple contract that keeps track of a single counter. Let's say we have this counter here that starts from 0 when it initializes the contract, and whenever somebody, a user, invoke this add transition, which is a function that you use, you will read the current counter state and then add 1 to it. So this is just a very simple ledger where every single person in the world can just interact with this contract and execute this step here and change the global mutable state. So you can imagine, what you can do with something like this kind of smart contract is that you can have an immutable ledger that everyone can view, and certain access parameters that a few individuals can change. Like transitions transitions can have like access rights, like the owner can change a certain aspects of the mutable parameters, or let's say it's only limited to a whitelisted few people who can change certain aspects of the mutable parameters. So there's a lot of use cases that we get done here, and that includes something that we spoke earlier of, which is the mindshare verification, that you can use a smart contract to hold the entire ledger to verify whether somebody has viewed the advertisement or not. So these are some commonly used types. You can view most of this in our documentations link. You can just go through this for now, but I will not go through directly right now because of the time. And these are custom ADTs, basically structs on steroids. You can construct within your contract. And I think this is one of the few contracts that you guys are most familiar with, which is ERC-20 contracts. In 2017, you have a lot of ICOs. Most of them are basically a simple few lines of codes. And we can break them down into certain parts within the Zilliqa language. It's like immutable variables. You have the owner, the total amount of tokens. Then you keep track of the balances and who's allowed to transfer the tokens. And you have different functions such as calling the basic balance, the total supply, transfer the tokens, who's approved to transfer the tokens, and who is allowed to transfer the tokens. So end-to-end application, how it works from the front end all the way to the back end, which is the blockchain. So your application can point first to the simulated blockchain first, such as the RPC server. And then once you are done with that development stage, you can deploy it over to the testnet. Testnet is where things are lesser at stake, and because there's no monetary value, that's there. And once your testnet application is proved to be secure, then you can move on to the real blockchain. This is how you start from conceptualizing all the way to the end production. And talking about the current RPC, which is a server replication of a blockchain, it simulates how the blockchain works. It's the reason why we want to use something like this too is so that you can debug and trace all the errors that's within your application. And then you can also save and resume states, and you have Genesis accounts, which basically means that we have 1 billion tokens that you can use. That's why you don't have to request for tokens or buy tokens in order to execute certain functions in a contract. So there's an install link here, and you can go to the GitHub if you want to install this tooling. And we have a JavaScript library right now, and we are planning to increase the language support SDKs such as C#, Java, Ruby, and so on and so forth. So right now, this is the JavaScript library that we have, and these are the different kinds of functions that you can go into. It's quite comprehensive, so everything that you require, such as creating a new wallet, interacting, deploying a contract, creating a transaction, all of them are all abstracted away from the developer and all put into these JavaScript functions. So you can just invoke a certain function here when you compile it, and then you can use it to interact with the blockchain. Getting started with JS, we have a JS starter that's created by Edison. He was here just now, and you can take a look at how you want to use the library that I previously explained to create your smart contracts. It's like a sample. If you wish to join our developer community, you can join us through the GitHub channel. I wanted to put a QR code here, but I didn't have the time to do so. Our GitHub channel is github.im/Zilliqa, and you can join us if you need any kind of technical support for creating your applications. And if you have any interesting ideas that you wish to apply for innovation grant, you can go to our grant link, which is linked in our Zilliqa.com website, and apply for the grant. So you are required to submit a 3-page proposal to illustrate the problem statement, the solution that you have, the technical stack that you need, and also the budget and timeline deliverables. So right now we have about 45 projects going on in the grant project. If you wish to join it, you feel free to approach me, Hanwen at Zilliqa.com if you wish to. That's all from me, and thank you for participating here. Thanks.